So the first thing we have to decide is whether or not we even need to use substitution. So on question number 1, look to see if you can simplify it algebraically, or if you can just, take the antiderivatives, term by term. And if you notice here, we can go ahead and distribute the 6w squared. So we're going to use algebra first. This will give us 18w cubed minus 54w squared. And then we still need to take the antiderivative with respect to w. All right, now I'm using my basic power rule, so I have 18w to the 4th divided by my new exponent. And then I have 54w to the 3rd power divided by 3 plus c. And the last thing you have to do is clean up your coefficients. So 18 over 4, I get 9/2 w to the 4 minus 18w cubed plus c. All right. You can always check your answer by taking the derivative. All right. So question number 2, same thing. I'm going to start off by seeing if maybe there's something I can do algebraically to simplify this. Remember that we don't have a quotient rule, so there's got to be some way to do this. Since I'm dividing by a monomial, one term down here, I can go ahead and take each term of the numerator and divide it by the denominator. So I'm just going to take 8x to the 3rd over 4x squared, 7x squared divided by 4x squared, and then 16x divided by 4x squared. I'm going to reduce all of these first and then take the antiderivative. So I have 2x plus 7/4. And for the last one, since I want to use my power rule, I'm going to write it as, I can write it as 4 over x, but I'm going to write it as 4x to the -1. And I still need to take the antiderivative with respect to x. All right. So now we're using our basic rules. I'm going to add one of the exponent. So remember our current exponent, if we don't want to see it, we know it's a 1. So adding one of the exponent, I have x squared and divide by my new exponent. So for the 7/4, it's a constant. We're going to get 7/4 x. And then the last one, if you try to use your power rule, what happens? So if you add 1 to the exponent, you get a 0. And then you try to divide by your new exponent. We can't do that. So that's another thing that should tip you off that it's not the power rule, it's the natural log rule. So 4 times, and then so the antiderivative of x to the -1 is the natural log of the absolute value of x. And we've always got our plus c. All right, cleaning this up, really I've only got to worry about the coefficients of the first term. We have x squared plus 7/4 x plus 4 times the natural log of the absolute value of x plus c. And like I said, when you've got time, it's a really good idea to take the derivatives. It helps you check your work, but it also helps you kind of see what's going on in between. It makes you see antiderivatives a little bit more clearly. Okay, so for number 3, now this one here I have to use substitution. If you notice, I've got stuff raised to the 7th power. If it were just t to the 7th power, I wouldn't need substitution. But for here, we need substitution. So I'm going to go ahead and let u be that stuff in the parentheses. And so the du that goes with it is going to be the derivative of t minus 5 is just 1 dt. All right. So now I need to make a substitution both for u and for du. So coming over here, in order to get a du, I need a dt, and I have a dt right there. So making my substitutions, the t minus 5 will be u, so it's u to the 7th, and then dt is replaced by du. And now I can use my basic power rule. So I end up with 1/8 u to the 8th plus c. And then don't forget you have to put this back in terms of the original. So u was equal to, remember right here you chose it, it was t minus 5. So t minus 5 to the 8th power plus c. Here's another one. Like I said, whenever we're using substitution, we pretty much have 2 choices. We're either going to go with u to the n du, or we're going to pick e to the u du. And so this is a case of e to the u du. So whatever I have in my exponent up here, that x squared plus 1, that's going to be my u. So currently I have, if I were to just substitute in what I know it right now, I've got x e to the u dx. That's no good because I'm mixing x's and u's. So I've also got to, like I said, get rid of the other x's, but I need to get a du in there. All right, so now that you have the u, take the derivative, and we get 2x, so du dx is equal to 2x, therefore du is equal to 2x dx. All right, so in order to substitute, I have to have a 2, an x, and a dx. I've got the x, I've got the dx, but I don't have the 2. Now remember, if you're only off by a constant, then you can fix it, okay? Because constant can come in and out in front of the integration symbol. So since I need a 2 in here, I can multiply by a 2. I just need to make sure that I'm also dividing by a 2. And I'm going to do that out in front. I don't need it in here. I'm going to move it out there so it doesn't get in my way. So now I have the x, the dx, and the 2. All of that together is replaced by du. So we have 1/2 antiderivative of, I've got e to the u times du. Okay. So taking the antiderivative of e to the u, we get e to the u plus c. And then our last step is to go ahead and substitute back in. U was equal to x squared plus 1, so e to the x squared plus 1 plus c. Okay. And again, when you take the derivative, make sure you're using the general exponential rule, the chain rule, to check your work. All right. Moving down to number 5. Okay, so number 5 maybe is not as obvious how to approach it. There's nothing we can do to simplify this algebraically. One option is I could take my denominator and bring it up and write it to the v cubed minus 6v to the negative 1 power. And so when you do it that might help you see that I'm going to use substitution, and it's going to be of the form, u to the n du. Okay. The other thing to do is to, just look at both the numerator and denominator and choose the one that's more complicated or has the higher power. If you let that be your u and you take the derivative and it doesn't match up with your du, then that's not the way to go. Anyways, okay, so once I raise this to the power, I know that I'm gonna let u be what's inside my parentheses here. So u is going to be equal to v cubed minus 6v. Therefore du is going to be 3v squared minus 6 dv. Okay, so that's the key. Now I have to make sure that both my u and my du are over here. Now the u is because I chose it, but what about the du? I have a v squared minus 2, and what I need is a 3v squared minus 6. So maybe you can see that it's only off by a multiple of 3. If not, if you factor this out, now you can see that all we're missing is the 3. Okay, so just like the previous problem, since I'm missing a constant, I can go ahead and put my constant in here as long as I also divide by the same number. So I have 1/3. Now I have u to the negative 1, and then the v squared minus 2, the 3, and the dv, all of that is equal to du. Okay, now we're ready to take the antiderivative. Hopefully you recognize this as being the natural log. So I got 1/3 times the natural log of the absolute value of u plus c. And now substituting in my u, the natural log of the absolute value of v cubed minus 6v plus c. All right, so for number 6. Okay, so here's another one. We have to use substitution. Like I said, if you look, you have a bunch of stuff raised to the 3rd power. So this is going to be like u to the 3rd. So our u will be y to the 5th plus 1. And therefore our du will be 5u to the 4th dy. I'm missing the 5. For my du over here, I've got the y to the 4th and the dy, but I'm missing the 5. So I will multiply by a 5, and I will also divide by a 5. So now I have 1/5, and then this will be the antiderivative of u to the third du. Using the basic power rule, I have 1/5, and this becomes u to the fourth over 4 plus c. And I have to clean up my coefficients. So this gives me 1 over 20. And then substituting back in for u, so I have y to the fifth plus 1, that's to the fourth power, plus c. There we go. Okay, number 7, here's another one that has e in it, and it's raised to the 3x power. So that's going to be my u. So u is equal to 3x. Therefore, my du is going to be 3 dx. Okay, so I know how to get the 3 in there. But what do I do with that 5? Like I said, I don't really need the 5, so I'm allowed to move it out front. I'm going to go ahead and just put this out front. And then everything else is going to be the same. So my u is 3x, and then for the du, I need a 3 dx. I'm missing the 3, so I'll put the 3 in here, but I'm also going to divide by 3. And so now I have my 3 and my dx to be substituted by du. So we have 5/3 antiderivative of e to the u du. Now we can take our antiderivative, so we have 5/3 e to the u plus c. And then again we substitute back in for u. So we have e to the 3x plus c. And again, like I said, it's a good idea for you to take these derivatives and check them. Alright, so here's another one. You can leave this in the denominator, you can bring it up to the -2 power. We're going to have to move it up at some point, regardless. So it's up to you whether you move it first or later. But it should stand out that, all this stuff here being squared, or like I said, if you bring it up to the -2 power, that's going to have to be your u. So u will be 2x squared plus 8x plus 3. Taking the derivative of this then, my du will become 4x plus 8 dx. Okay, and like this similar problem, I said, well, I need a 4x plus 8. I have a 3x plus 6. And like I said, they're similar, they're not the same, but how do I fix it? If I factor these, then I can see that I have 4 times x plus 2. And then up here, if I factor this one, I have 3 times x plus 2. Okay, so I've got the x plus 2 there. I'm just missing the 4. And again, since I'm missing a constant, I can fix it. And just like I did on the previous problem, this 3 I don't need. So I'm going to go ahead and bring it out front. So let me rewrite this whole problem. So I'm going to put the 3 out front. And I have an x plus 2 in the numerator. And then we have 2x squared plus 8x plus 3, that quantity squared in the denominator. Okay. And now I'll do my substitution. So like I said, I know what my u is. I got my u here. Okay. And then for the du, I'm missing the 4. So I put my 4 in here. I put my 1/4 out front. And then I can take the x plus 2, the 4 and the dx. All of that is replaced by du. And so we have 3/4 times the antiderivative of u to the -2 du. And now we use our basic power rule. So I add 1 to the exponent, divided by my new exponent, plus c. And so cleaning up my coefficients, this becomes a -3/4. Substituting back in for u, which we chose to be 2x squared, plus 8x plus 3, to the -1 power, plus c. Alright. Another one down. Alright, 2 more to go. Alright, number 9. Now if we were taking the derivative of this expression, the first thing we would do is see the radical and say we need to write that to the 1/2 power. Same thing works for antiderivatives. So I'm going to start by rewriting this as 3z minus 5 to the 1/2 dz. My u, then, like I said, is going to be obvious. It's going to be that stuff in the parentheses. So it's 3z minus 5. And then my du taking the derivative here, I get 3 dz. Like several of the other problems we've done, I'm missing the 3. It's just a constant, so we can put the 3 in here as long as we bring the 1/3 out. And so now my 3 dz is substituted by du. So we have 1/3 antiderivative of, this becomes u to the 1/2 du. And now we take the antiderivative. With exponents, so I add 1 to 1/2 and I get 3/2, so that's u to the 3/2. And then I divide by my exponent. You know, anytime you're dividing by, you know, a fraction, you're multiplying by its reciprocal. So times 2/3. Okay. And now multiplying my coefficients over here, 1/3 times 2/3, I get 2/9. And then we have u to the 3/2, so where u is 3z minus 5, so that's to the 3/2 power, plus c. Okay. Alright, and here's number 10. Number 10 I had worked out in class, so I'm going to kind of just go over a little bit. Again, this isn't similar to the others in that it's not really obvious what our choice is. We don't see anything raised to a power, we don't see e to the x. Like I said, go with the one that's more complicated. So this is definitely the more complicated, comparing natural log of 8x versus x. So I'm going to let u equal the natural log of 8x. So when I take the derivative, my du, remember the natural log, so it's going to be u prime over u, so 8 over 8x dx. And then simplifying this, I have 1 over x dx. Okay. So over here, there's my for du, I need to have a 1 over x dx. So I have that already. There's my 1 over x dx. So I end up with u to the first power times du. And now we use our power rule. And again, my exponent is a 1. So I add 1 to my exponent, divide by my new exponent, plus c. And now substituting back in for u, I have the natural log of 8x, this quantity squared, over 2 or times 1/2 plus c. Alright, let me know if you have any questions.